Welcome to HB Tuner's Ford Gen 1 Coyote Training Part 24. In this training module, we're going to be taking a look at how we can dial in our torque tables using log data in our histograms from our VCM scanner to repopulate and recalculate our torque and inverse tables so we can get rid of our wheel torque errors and we have our torque calibrated properly within our ECU. We're going to have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at dialing in our torque tables for our Gen 1 Ford Coyote applications. Our torque table tuning needs to be set up properly or else we'll get all kinds of wheel torque errors which can cause drive-by-wire throttle shutdown. So it can cause all kinds of problems for us. There's going to be a really straightforward way to dial this in and I'm going to be sharing that here in this tutorial. Let's jump in and first talk about how the torque and drive-by-wire system are related to each other, looking up certain tables so we understand how they're going to work, and then we'll talk about the flow of logic through the Ford programming so that we understand what exactly we're trying to accomplish. Once we do that, we'll make some changes to our file, we'll go ahead, we'll flash it, log it, take a look at what to look for in the VCM scanner. I've set up all kinds of histograms, channels, and chart versus time so we can see exactly what's going on. And then I'll model how we're going to be correcting the problem here in this tutorial. It seems really complex, but I'm going to break it down so it's really straightforward so that you're able to replicate this again on your vehicle. That's the goal here, to be able to do this efficiently and do it quickly. So a couple things. Let's start off the tutorial here. I want to go and take a look at where we can find our torque tables and the torque system, just explaining how this is all going to work. Let's jump in here into our calibration file. This is the same file I've been using in several other training tutorials. So the mass airflow, speed density, variable cam tuning, doing all of those. We've calibrated everything out. We know that they're all good. That's why I'm going and leading into the torque tuning right now. I like to tune my MAF, then the variable cam, then the speed density, and then the torque. Because the torque modeling can be thrown off if our variable cam is changing the way the engine's breathing, which throws off then obviously the speed density. So MAF, then the variable cam mapping, then the speed density mapping, then the torque table tuning is always the order of operations that I prefer to move, and I think it makes the most sense. So let's go in here and take a look at what we can find here into our file. So this is that file that I've been working with, just saved as torque table tuning, just for reference here. Let's go up to the top. We're going to move across towards the last two tabs here. Let's jump into torque model and let's take a look real quick. We're going to find we have these tables, torque calculation tables. These torque tables are used in our drive-by-wire system. If we pop into a table here, we have, let's just take a look at our optimal performance table. We're going to find the table here is based on air load, and engine RPM at the top. The values in the table itself, they're in torque language or torque values that we want to go and see and run. These values are going to be known as the engine indicated torque or the scheduled torque. That is going to be the torque that the engine is making before we account for any frictional losses or pumping losses. So this would be essentially, in a perfect world, what kind of torque the engine should be making. Now, if we take a look over here at loss, this will be modeling a frictional loss or altitude correction or pumping losses that we would find for the engine. So we'll find that these, again, these values here, this would be known as scheduled torque or engine indicated torque. These values are going to be before we subtract any frictional losses and have actual flywheel torque, or what the engine's actually making would be outputting to the transmission or to the flywheel. So we're going to find that's how these relate. Now, what we're going to find here is that we have our engine torque OP table. We also have our inverse table. The inverse table is going to be taking a look at something called our scheduled torque. So that's our engine torque. It's coming from our table here. It's going to look at engine speed. It's going to look at a lookup value here. This lookup value will then allow us to calculate how to open the throttle. So it's going to be allowing the throttle plate a translation into opening. Now, what's driving all of this, what's actually allowing the torque tables to turn into a throttle plate opening, is going to be driven from what's known as, in torque management here, our driver demand. The driver demand table, if we take a look here under normal engine, we're going to find that we have this table here. This is going to be taking a look at what's called accelerator pedal position. This is ADC counts or analog digital counts. The programming language here in terms of translation of throttle plate movement over the pedal movement, I'm sorry, the actual pedal that we put our foot on in the car, it would be 0 to 600 in terms of the scale that you'd expect to move in here. That's just an odd scaling factor they have going on. So this is going to be our ADC pedal position counts versus engine speed. And the values in the table here are going to be our, and what's known as our ETC torque request. The ETC torque is going to be after we've accounted for any frictional or pumping losses. So this would be what we would expect for a flywheel torque, what would the engine would actually output. And this is going to be what we like to see at a given pedal position. So this is going to essentially drive our engine response by having our pedal plate relationship. If you're used to doing any kind of tuning with standalones and drive-by-wire, we would have a typical pedal input and be able to tell, the ECU would be able to tell the plate how to open in relation to that pedal. This is going to be how Ford deals with it in terms of this high-level programming language that we have going on here. We're essentially taking a torque-based system and allowing a pedal input to translate to a torque request to go through the torque modeling to then open the throttle plate. Seems pretty complex, and it is, so I just want to try to keep this as simple as possible. We don't need to know every single bit of math behind what's going on here, but just the flow of logic is important to understand conceptually what we're trying to accomplish here. Now, I've went over the torque model, just understanding that that translates to the throttle opening. This is our torque request.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.